So here we have number 12, solve the linear quadratic system using substitution property. And this one's really just the transitive property. Notice how both of these are set equal to y. That means they're going to be equal to each other. So I know that x minus 4 equals negative x squared plus 6. And, your goal here is ax squared plus bx plus c equals 0. That's been talked about and talked about and talked about. If you have a quadratic, you're going to set it equal to 0. And the way I wrote this one, it makes a lot of sense to shift everything left. That's going to make the x squared positive. That's going to keep that x positive because it didn't move. And you need to be thinking, what's negative 4 minus 6? It's negative 10. Now, this one does not factor. It is kind of an ugly little problem. It doesn't factor. Sorry about that. I know it doesn't factor because can you think of factors of 10 that add to 1? So you're going to do the quadratic formula. You're going to sing a little song. The little song goes something like this. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Or you can do the complete square method. Anyways, b is positive 1. That's going to make that a negative 1. Plus or minus a1 squared minus a4 times a, which is 1, times c, which is 1. All sitting pretty over 2a. And a is 1. There you go. And then we're just going to crank out the math. This one does not have any real solutions, actually. We have a no real solution system. We have 1 squared minus 4, which is negative 3. And it's all over 2, or both pieces over 2. And the root of 3 is imaginary. So what we can tell from this one is it has no real solutions. Now, does that mean that the test has no real solutions? No. Now, what you will have to do, because it's going to have real solutions, kids, is you're going to have to plug these things back in. So y is going to be negative 1/2, and I'm looking at this first equation here. It's the easiest one to work with. Negative 1/2, we'll do the positive, plus I roots of 3 over 2 minus 4. And we can only combine like terms. Negative 1/2 minus 4 is negative 9/2. Think about that. Negative 1/2 minus 8/2. That's negative 9/2. So we have negative 9/2 plus the imaginary root of 3 over 2. Or what would happen if we plug in the negative? Well, this becomes a negative, and the numbers stay the same. Negative 9/2 minus the imaginary root of 3 over 2. And if you remember this or not, those two things are called complex conjugates of each other, just like those two things right here were. But anyways, your test 12 is going to be easier. It is, I promise you. Determine the number of real solutions of the following systems. This is a graphing exercise. In a perfect world, a kid would be able to do this mentally in their head, but this is not a perfect world, and you nor I are perfect people. Fall one, run one, fall one, run one. I'm doing the bottom line there. X squared plus 5 is a shift up 5. 1, 2, 3, 4, 5. Rises 1 both ways to form the parabola. No solutions. No solutions. Y equals x squared plus 2 and 2x plus 4. And again, just like I did in the original twin, I'll do one of these in a calculator just to justify and help you guys out. You can use a calculator if you really have to. 2x plus 4, we rise 2 and run 1. Looks like that. Now the parabola crosses the y-axis at 2, and she has an initial slope of 1, rises 1, runs 1 both ways. And you can see that this is going to have 2 solutions. And again, I can, and a lot of the students in your class, they can visualize these things, and they don't have to go through this process. It'd be really cool if you became that kid. It would be. It'd be awesome. It would be. All right. Here we have x plus 3, 1, 2, 3. We rise 1 and run 1 because there's an understood 1 in front of x. Now everybody and their mama has been doing slope-intercept form for quite some time. Fall 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And the slope here is negative 1. We have an a value of negative 1. So it's going to fall 1 and run 1 both ways. And there's your parabola. And you can clearly see that there are no solutions. These might be the same as the ones I did on the first one. I don't know. That was yesterday, and I don't remember yesterday. But we have negative x to the second. And this should be a skill that like nobody misses. But boy, it's going to be bad. There's going to be a number of kids who try to solve the system and just waste hours of time. Anyways, Milbrath taught you, trained you to do a Zoom 6. That's where it's at. Now, you're not going to see anything, and you won't realize this because a lot of you don't understand what the negative 12 does. You're going to have to look down to see it. I'm going to go to my window settings. I'm going to change my Y minimum to be something like negative 30, just so I can see a good picture of the parabola. You wanted to go farther than negative 12. Negative 20 would have done the job. Negative 15 probably would have been okay. But you know, there's the graph off of TI-84. And how do we know it has no solutions? Because she has no intersections. Moving forward, this one's going to go better than the one on the first twin. To have one real solution, b squared minus 4ac must equal a 0. So a is 4, b is oddly enough b, and c is 16. And this one's going to work out better. So b is b squared minus 4 times a, which is 4, times c, which is 16, must equal a 0. Now, if we do 4 times 4, we get 16. If we do 16 times 16, we get 256. Please don't be lost in the calculations, okay? I don't often show it. And I know that number sense is an issue, but I literally just typed in negative 4. I typed in my head, I did negative 4 times 16. I got negative 256. The easiest way to figure this one out is to shift the 256 over and then fix a square by square rooting. And I don't know if you caught on to this, but it took a pair of 16s to do it. B is plus or minus 16. There's some things that you're expected to know, and you're supposed to know that 256 is a perfect square. It is 16 squared. So plus or minus 16 is the solutions. It says it'll be easier on the test. I think that's because this is more in line with what's on the test. The test is not a hard problem. It's not going to get any easier than this. All right, moving on to number 9. A vandalist throws paint balloons at cars during rush hour in downtown Memphis. The balloons are thrown with initial acceleration of 64 feet per second from initial height of 6 feet. Do you have any idea 20 in 77 kids will miss part 1? Prove me wrong. Height as a function of time is negative 16t squared. V is the initial acceleration. Like I even say in the text what things are. I don't think you know how to read. 64t. HO is the initial height that's in the text. It's 6 feet. Like it's just plug into a form and go, man. That's not upper level math. Anyways, there's part 1. Will the balloon reach a height of 70 feet? It does not have to be actually solved. It's a b squared minus 4ac part. And a lot of you guys did not do this part of the worksheet, but there's some rules here. If b squared minus 4ac is equal to 0, you have one real solution. If b squared minus 4ac is greater than 0, you have two real solutions, okay? So what I want to do is I just want to do the b squared minus 4ac part once it's in standard form. So this is going to get moved over here. It doesn't really matter here if the a's, b's, and c's are negative or not. It doesn't, But anyways, we'll just use these numbers as they are. So this is A, this is B, this is C. So I'm just going to figure out what 64 squared minus 4 times a negative 16 times a negative 64 is. Those numbers are a bit big. I don't feel like calculating them right now. 64 squared minus 4 times negative 16 times a negative 64 is 0. So you can see that it actually met that, didn't it? It meant that requirement. So will it reach 70 feet? Yes, because b squared minus 4ac equals 0. That's how I answer these on the test. Like, you have to pick which of these scenarios is true. So yes, because b squared minus 4ac is equal to 0. All right, number 3, assuming the paint balloon hits a lifted truck's fender, which is 5 feet above the ground, how many seconds will it take after the vandal releases the balloon to hit the truck? So on this one, we're going to put the 5 in for the height. It's 5 equals negative 16 t squared plus the initial velocity of 64 t plus 6. And I legit want you to do y1, y2. That's what I want you to do. Will you do it? Probably not. We shall see. So I'm putting a 5 in y1. And I'm putting a negative 16x to the second. By all means, play along, because you and I both know that you probably don't know how to use your calculator properly. And I don't say that negatively. It's just the truth. I mean, I grade everything y'all do. You don't play along. You know, the goal is to get a 60 for a lot of y'all. And you're not doing it. So we don't even have the full picture here, but you should imagine that the parabola go up and parabola go down. This solution is probably negative time, which is nonsense. This is the one you want. It doesn't make sense either, because he threw the height, the initial height was 6 feet. So 5 feet is going to beat that. It goes up and it smashes into the truck right here at this particular time. Second, trace 5 for intersect. Take your little cursor and get her close, get her in the neighborhood of that intersection, and press enter 3 times, once, twice, thrice. And there you go. It's about 4.01556 seconds. One, 5, 5, 6 seconds. That's too many. 156. 4 decimal places. Seconds. Ta-da! All right, number 8, up above this one, solve using the quadratic formula. This is at least the 3rd time in this one I've written it down for you. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Sing the song, and you will know the quadratic formula. And this one's given to you in standard form, so you're good to go. A is 1, B is 3, and C is 5. So x would be opposite of a positive 3, which is a negative 3, plus or minus the square root of a 3 that gets squared, minus 4 times A, which is 1, times C, which is 5, all sitting pretty over twice a 1. So we're going to have negative 3 plus or minus. If you can't do math in your head, push buttons. This is 9 minus 15, which is negative 6. Both pieces sitting over 2 times 1, which is 2. You should know by now that the square root of a negative is imaginary. You will notice that I do not try to divide that 6 by 2 because I cannot, because it's not 6. It's actually a number just a little more than 2. 2 point something. That's why I'm not doing the division. Maybe you get that, maybe you don't. But there's your 2 answers, kids. One of them is negative 3 halves plus the imaginary root of 6 over 2, and the other one is negative 3 halves minus the imaginary root of 6 over 2. By the way, these are conjugates. It's a word worth remembering. Conjugates. Pause and be right back. I need a break. All right, here we go. A function is defined by the equation y equals x squared plus 5x minus 5. Now, first off, since it starts with x to the second, it is a quadratic, which means the graph is a parabola. Everybody and their mama, and their mama's mama, and their mama's mama after that knows that the domain of a parabola is negative infinity to infinity. To find the range and some of the other stuff, you're kind of going to have to be thinking about a graph, kids. That, you're going to have to be thinking about a graph. I actually don't really have a problem doing parts 2 and part 4 with a calculator. I really don't. In fact, for the purpose of this twin, I'm going to teach everything in a calculator. I do want you to pay attention here that A is 1. And that comes into play over here in vertex form. A times x minus h quantity squared plus k. There's going to be an understood 1 there, right? Hopefully you grasp that concept. Anyways, let's just separate the kids who can use a calculator from the kids who can't. So we're going to throw x squared plus 4x minus 5 into our TI-84. I hate teaching this way, but I am just, your grades are so bad. It's so sad. Makes me cry. Zoom 6 it, just like I've taught you to. And look at this thing. Like, this is the thing. If I want the range, I have to know the x and y values down here at this point we call the vertex. So second, trace, and take whatever notes you need to take, man. That is a minimum, is it not? Minimum. That's the bottom of a graph. It works by getting a left boundary and a right boundary. You take your cursor, you get it to the left of that minimum. You press enter. Then it wants a right boundary. You get your cursor to the right of that minimum and you press enter. And then you press enter for a guess again. And you got a nice number. The vertex is at -2, -9. Now, y equals -9 is the minimum, and the graph rises on either side of the vertex. So your range is -9 to infinity. The function's minimum was literally y equals -9. Now, I don't know if you caught on or not, but when I found the coordinates of that minimum, I also found the coordinates of the vertex. This thing had a vertex at -2, -9. And the vertex gives us the letters h and k. So we already have the 1 that's understood. If we take away a -2, we shall be positive. And then we always trust the sign on k, -9. That's the vertex form. It ain't even that hard, man. Moving on to number 6. Write the quotient 34 over 3 minus 2i in the form a plus bi. We're going to do that by multiplying both the numerator and the denominator by the conjugate of 2 plus minus I. And the conjugate of 2 minus 2i is 2 plus 2i. And I'm going to show you something after this, just because I don't think a lot of kids are going to do the bonus quiz, and that's their fault. It's not your fault. If you're doing the bonus quiz, you should always do the bonus stuff, kids. It's not a suggestion, really. 34 times 2 is 68. 34 times 28 is 68i. Now, down low, 2 times 2 is 4. A -2i times 2 is a -4i. 2i times +2 is 4i. They cancel. A -2i times a +2i is a -4i squared. Remember that I squared is -1. And then -4 times -1 is +4. So what do we have thus far? Thus far we have 68 plus 68i, both pieces sitting over 8. And there's a reduction that's doable. Both those numbers are divisible by 4. I guarantee you they are. 4 enters 68 17 times. 4 enters 8 twice. And there you go. Now watch this. Let's see here. Let's bring up my fraction command, the math num n over d. It'd be really cool if Spencer was watching this. 34 over, oh man, I'm glad I did this because I made a typo and I've got to redo my math here. I for some reason saw 2 minus 2i and it's 3 minus 2i. Really? It couldn't do that. The TI-84 used to be able to do that. That's interesting. Okay, never mind. I'll show you something else. But okay, let's go back and fix Milbrath's mistakes. 3 and a 3. So that's going to make this a 9, right? And that's the only thing that's going to change. That's going to make that a 13. And that's actually where this problem stops. Okay, so I still do want to show you something. Oh, I got to change the top too. That's a 3. 34 times 3 is 90, 112. That'll fix it. Got to watch out for making mistakes when you write things down. So we got 112 plus 68i over 13. And those things do not reduce. Okay, so I couldn't show you what I wanted to show you because the calculator just couldn't do it. But it could have done some of the math for you. I did 34 times 3 plus 2i. If you hit second period, you bring up the I key. And apparently I can't multiply today. 102. Third time's a charm here. Glad I'm checking it. Plus 68i. I got the 68i part right. Down low, we did 3 minus 2i. And we're going to multiply it by 3 plus 2i. Let's see if I got that 13 right or not. And I did. Okay, so good. So we have 102 over 13, which I don't think simplifies. I would be shocked. I don't feel like doing the math in my head right now, and it doesn't. So it's 102 over 13 plus 68i over 13. All right, identify the intervals on which the function y equals negative x squared plus 5x plus 24 is positive. It'd be really cool if y'all could do this without technology. It would be. It'd be awesome. So I'm going to do both. I'm going to set the thing equal to 0 because I'm going to find the x-intercepts. And I'm going to divide out the negative 1 to make these things positive, at least the x squared positive. Then I'm going to factor. Take some x and an x to make an x squared. Factors of 24 are going to be 8 and 3. And a negative 8 plus 3 is a negative 5 in the middle. So what happens is I cross the x-axis using the zero product property at x equals 8, 3, 6, 7, 8, and x equals negative 3, right there. Now you see that? Opens down. It ain't perfect, but it's good enough. There is such a thing as good enough. The reason I'm highlighting that territory is because that's where the graph is positive. I am positive between x values of negative 3 and 8. As an inequality, that's negative 3 less than x less than 8. As an interval, that's negative 3 comma 8. Either one of them works. Now, again, let's go over using a TI-84, which for some of you it might be easier to do. For me, it's quicker to just do the thing by hand. So I'm going to y equals, I'm typing in x squared plus 5x plus 24. And I'm going to do a zoom 6. There's a couple of different ways of finding x-intercepts on TI-84. You can graph the line y equals 0, which is probably the best way because it helps establish the relationship between zeros and x-intercepts. So I'm going to put a 0 into y2. Second trace 5 comes up. I'm going to take my cursor. I'm going to go after the left boundary, and there you'll see it. It's at negative 3. And you can probably count these ones out. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, this graph that I've got on my TI-84 is pretty much the same thing that I just did by hand, right? And I'm not even going to worry about getting the whole parabola. I just want that. And if you followed along on my reasoning on the last one, it's that stuff right there. And the numbers are still the same. They are. I am still a number stuck between 3 and 8. That's about being positive. If it was negative, it'd be something else. 4, use quadratic regression. Quadratic regression is not hard to do. You just place your x's into list 1 and your y's into list 2. And then you press stat, calc, quad reg. By the way, to get here, you go to stat, you just choose edit. And again, play along, like go pull out, get a calculator, go to ti84calc.com and fire up a calculator and play along, kids. I know you don't have calculators. That's why I told you where to get one. Anywho, stat edit. See if I've got some of these in here already. -2, 0, 2, 4, and 6. -2 has a value of -10. 0 has a value of -12. 2 has a value of 2.7. 4 has a value of -13. And 6 has a value of -42. And then I'm just going to do what the instruction set said. I'm going to go to stat, I'm going to go to calc, I'm going to go to quadratic regression. I don't know why I hit the up arrow there. I went the long way, took the scenic route apparently. And then I'm just going to drop on down to calculate. You would think that every student in class gets this right, but there's going to be at least 10 that miss it. Please prove me wrong. Please prove me wrong. You know, when somebody says you can't do this, the correct response is prove them wrong. So I'm saying a lot of you will miss this problem. Prove me wrong, okay? I don't know if I have this thing multiple choice or not, but the equation is -1.5071x squared. See how it says A plus 2.7786, this is B, x plus the constant minus 2.3314. Now, you'll see where my calculator has this r squared value. Your calculators will have this turned off. You'll have to turn it on. Hit second, 0. Scroll down until you see something called diagnostics on. You're going to see something that got Milbrath in a lot of trouble. And isn't that ridiculous that that got me in trouble? Here she comes. Remember her? Crazy. Take it up with TI-84, kids. Not Milbrath. Anyways, diagnostic on. So what you got to press? Press enter. There you go. Now, whenever you do this, quad reg, it's going to be there. And you should do this first, by the way. That's how you pull up that value. And it's not an R value, it's an R squared value. It says R squared is about 0.8622. Now that's R squared. R would be the square root of 0.8622, which is going to be a slightly bigger number. .9285. So if the absolute value of R is close to 1, we have a strong relation. Now this is a quadratic. We have a strong quadratic. And I don't need to be saying the correct word, correlation. We're saying that X is correlated to Y, and we're going to have a whole lesson about correlation come probably March of next year. It's just something I'm introducing right now. Some of you will remember it. All right, 2, function G is a transformation of the mother function f of x equals x squared. G has been translated left 3 and up 2. By the way, this is H. H is -3. This is K. K is 2. We're going to start with vertex form. And notice it doesn't talk about vertical shifts, so it's just 1 times x. Let me write this down. Minus h squared plus k. If you plug in a -3, you're going to have a positive, right? Because taking away a negative is positive. And then plus 2. You start with vertex form, and you work your way into STD form, into standard form. So I've said this a couple dozen times. If something's squared, that means it was written twice. A lot of y'all are box kids. You don't have to do the box. There's nothing wrong with the box. I kind of like the box. Some kids are before the box. X times x is x squared. X times 3 is 3x. X times 3 is 3x. 3 times 3 is 9. This piece creates x squared plus 6x plus 9. And you still have to add the 2. And last I checked, 9 and 2, when added together, made 11. And that is the standard form. And the last one in this twin, and I can be done with this video. Praise the Lord, because I did it backwards, is number 1. What is the equation of a parabola in vertex form that has a vertex at -5, 7 and passes through -1, 0? So this gives you h, this gives you k, this gives you x, this gives you y. You are plugging into the form y equals a times x minus h. Don't forget the square plus k. And don't do it all at once. If you take away a -5, you shall be positive. Always trust the k value. Now we find a. I am going to take these numbers, and everywhere I see a y, I'm going to be a 0. Everywhere I see an x, I'm going to be a -1. The 7 belongs over here. Go ahead and move that first so you don't do anything with it, because sometimes you'll mess it up. -1 and 5, I'm pretty sure makes a 4, but you still have to square. If you square a 4, you get a 16. Divide out the 16, and a is -7/16, which is a pretty common wrench size, isn't it? Anybody ever use a -7/16 wrench? Pretty common. Anywho, that number goes there. And here it is, your equation. Y is -7/16 of x plus 5 quantity squared, add 7. And that's your bonus twin. I hope you did it. I did it. You should do it. I didn't even need to do it. And I still did it for you. Anyways, good luck Friday.